modulation technique, and what is the quantization noise in that PCM? What is the expression for the quantization noise in the PCM? In previous class we have discussed what is the quantization noise if the peak to peak of the message signal is 2 MP, or peak value of the positive peak value of the message signal is MP and negative peak of the message signal is minus MP. Then what is the quantization noise? And the L represents number of quantization levels. Number of quantization levels. Then what is the quantization noise? Anybody? If the quantization step is yes, if the quantization step is yes, then what is the quantization noise? Have you noted that derivation that we have discussed in the last class? What is the quantization noise? What is the expression for the quantization noise?
MP square by 3L square.
2 MP square by
3L square.
3L square. What is L? What is L?
Levels.
Number of?
Levels.
Yeah, number of quantization levels. Number of quantization levels. Okay. If the number of quantization levels is equal to L, then how many bits are required to encode that quantization levels? How many bits are required? In previous class we have discussed. If L is equal to 8, then how many bits are required to encode that 8 possible levels?
4 bits.
Huh?
4 bits.
No, not 4 bits, 3 bits. Because by using 3 bits, how many possible combinations will be there? 2 to the power of 3. 2 to the power of 3 indicates 8 possible combinations. 2 to the power of 3 indicates 8 possible combinations. Okay. Do you see my screen
No, sir.
now?
Yes, sir.
Say an analog signal is there. An analog signal is there. This is an analog signal. We take the samples at different time intervals of Ts like this. Okay, and these samples are mapped to or rounded to any quantization value. These samples are mapped to quantization value. In previous class, we have seen if there are 8 quantization levels, L is equal to 8, then 8 quantization levels can be encoded by using 3 bits. 3 bits. Because suppose 8 quantization levels are What are the quantization values? From 0 to 1, the mid value is 0.5 or 1.5, 2.5, 3.5. Okay. Minus 0.5, minus 1.5, minus 2.5, minus 3.5. So 8 possible levels, and all these possible levels are converted into binary numbers by using 3 bits. That is 000, 001, 010, 011, 100, 101, 110, 111. So these are the binary numbers. So in this way, an analog signal can be converted into digital signal. For example, if number of quantization levels is equal to 16, number of quantization levels, that is 16 intervals, 16 intervals are there. Then number of, in each interval, the mid value represents the quantization value. In each interval, the mid value of that interval represents the quantization value. If 16 quantization levels are there, then how many number of bits are required to encode these 16 levels?
4, sir.
4.
4.
Because 2 to the power of 4 is equal to 16. 2 to the power of 4 is equal to 16. What are those combinations? 0, 0, 0, 0, 0, 0, 0, 0, 1, 0, 0, 1, 0, 2, 1, 1, 1, 0, 1, 1, 1. So totally 16 combinations are there. So all these 16 levels are encoded by these 16 possible values. Say 16 digital combinations. Okay. So what is the relationship between L and N? L is equal to 2 to the power of n. L is equal to 2 to the power of n. So if you use L quantization levels in PCM, then the number of bits which are required to encode that quantization levels is given by the relation L is equal to 2 to the power of n, or n is equal to, can anybody tell what is n in terms of L? L is equal to 2 to the power of n, then what is n? Do you know or not? L is equal to 2 to the power of n. Then what is the n in terms of L?
Log L by log 2.
Log base to L. Log base to L. Okay. What is log base to 4? Sorry. What is log base to 60? This is equal to
4.
log base to 16 is equal to log base to 2 to the power of 4. So this is equal to 4, no? So n is equal to 4. N is equal to 4. Okay. So this is the relationship between L and M. L and M. Okay. Now you note down output signal to noise ratio. Output signal to noise ratio. And bandwidth of pulse code modulation. Output signal to noise ratio and bandwidth of signal to, output signal to noise ratio and bandwidth of PCM. That is SNR and bandwidth. Let us discuss about signal to noise ratio and bandwidth of the pulse code modulation. In the first starting classes, I told you what we learned in the first unit. In that discussion, I clearly told you after completion of this unit, you should be in a position to calculate the signal to noise ratio, bandwidth of different modulation techniques. Okay. So that is the outcome of the first unit. Okay. So let us discuss about how do you calculate signal to noise ratio and bandwidth of different waveform coding techniques. Waveform coding techniques means pulse code modulation, differential pulse code modulation, delta modulation, like this. Up to now, we have discussed about pulse code modulation. Let us discuss about how do you calculate signal to noise ratio and bandwidth of the PCM. You please note down SNR and bandwidth of PCM. Okay. You please note down the power of message signal. You please note down the power of message signal in brackets output signal. The power of message signal in brackets output signal is given by S naught is equal to PM. The power of message signal in brackets output signal is given by S naught is equal to PM. S naught is equal to PM. And next you note down the quantization noise. The quantization noise, that is N naught. The quantization noise, that is N naught, is given by NQ is equal to, what is the quantization noise? What we have got in previous class? What is the expression for the quantization noise?
MP square by 3L.
MP square by
3L square.
3L square. MP square by 3L square. Then what is the signal to noise ratio? S naught by N naught. Signal to noise ratio, that is equal to PM by MP square by 3L square. So this is equal to 3L square PM by MP square. What is MP here? Maximum peak, that is peak value of the message signal. What is PM here? Power of the message signal. Power of the message signal. Here MP represents, here PM represents message signal power, and MP represents maximum peak of message signal. What is else? L is there. L indicates number of quantization levels. Number of quantization levels. Okay. So this is about signal to noise ratio of the PCM, that is given by 3L square PM by NP square. 3L square PM by NP square. Okay. Next, you note down bandwidth of PCM. Bandwidth of PCM. Bandwidth of PCM. You please note down. Consider a binary PCM. Consider a binary PCM with n binary bits with n binary bits with n binary bits assigned to each of L quantization levels. L quantization levels. Okay, n binary bits are assigned to, consider a binary PCM with n binary bits are assigned to each of the L quantization levels. Then what is the relationship between L and N? L and N. L is equal to 2 to the power of N, or N is equal to log base to L. Log base to L. What is L? L indicates number of quantization levels. Number of quantization levels. Can anybody tell what is the number of bits? Number of bits per sample? Here, what is the number of bits per sample? Pick the answer, Chapale. What is the number of bits per sample?
L by N.
L by N. No. You just have a look on this matter. How many bits are assigned to each of L quantization levels? Each of L quantization levels?
N bits.
N bits. So then what is the number of bits per sample? Number of bits per sample?
N by L.
No. Not like this. For example, there is a message signal. Okay. Here I take the samples at different time intervals. Okay. Here I write the sample values. Here I write the sample values continuously. Suppose at t is equal to 0, at t is equal to ts, 2 ts, 3 ts, like this. I continuously write the numbers 4 ts, 5 ts, like this. Suppose at t is equal to 2.3, after 3.2 and 1.6 and minus 2.3 minus 2.6 and so on. Suppose. Are you okay? Up to this point, these are the continuous samples. Say yes or no?
Yes, sir.
Yes, sir.
Okay. These are the samples. These are the samples, continuous samples. The first one is 2.3 represents this sample. The second sample 3.2 represents this sample. The third sample 1.6 represents this sample. Like this. Minus 2.3 represents this sample. Minus 2.6 represents this sample. Okay? These are the samples. Continuously I have the number of samples like etc. Now what happened? Each sample is mapped to nearest quantization value. No? Nearest quantization value. Suppose in this example I have 8 quantization levels. 0.5, 1.5, 2.5, 3.5, minus 0.5, minus 1.5, minus 2.5, minus 3.5. Okay, how many quantization levels are there here? L is equal to 8. L is equal to 8. If L is equal to 8, how many bits are required to encode each sample? 3 bits.
3.
N is equal to 3 bits. Okay. Here what happens, for example, I consider the first value, sample value. Okay. Sample value and that corresponding quantization value and the corresponding bits. Here I give the complete picture. For example, I take the sample value 2.3 and what is the next quantization? Next sample 3.2 and 1.6. No, 3.2, 1.6 like this. Now this 2.3 is converted into what quantization value? That 2.3 lies between which range?
2 and 3.
2 and 3. Then it is mapped to which value?
2.5.
2.5. 2.5. And 3.2 is mapped to
3.5.
3.5. And 1.6 is mapped to
1.5.
1.5.
1.5. Okay. Now these 2.5, 3.5, 1.5, all these are any one value of a set of 8 values. No, any one value of a set of these values, 8 values. No, so the 2.5, what is the corresponding? Sorry, what is the corresponding for the 2.5? Suppose 0.5 is 000, 1.5 is 001, 2.5 is 010. So this is equal to 010. So a sample 2.3 is mapped to 2.5 volts and the quantization value 2.5 is converted into 010 binary combination. So at the receiver, if receiver receives the 010 binary sequence, then it can understand, so okay, this 010 is related to 2.5 volts. In this way, it can reconstruct the quantized value. Okay. See next 3.5, 011. Okay, 1.5, 001 like this. Okay. Now you tell me how many bits are required for each sample in this example. How many bits are
3.
3 bits.
3 bits, no?
3, sir.
Okay. If you see this by an analog signal, if you see this analog signal, this analog signal is converted into sampled signal, sampled values like this 2.3, 3.2, 1.6, minus 2.3, minus 2.6 like this. And each sample is converted into quantization value. Each sample is converted into quantization value and that quantization is converted into corresponding binary bits like this. So finally an analog signal is converted into sample signal by sampling and it is mapped to quantized signal by using quantizer, and it is converted into binary signal by using encoder. Now you tell me, the number of bits per sample. How many bits do you require for each sample?
3.
3. But in general case, yeah, number of bits
N.
per sample is equal to number of bits
N.
per sample is equal to Okay. Suppose a signal m of t is there. A signal m of t is there. Signal m of t is there, whose highest frequency is, you please note down, highest frequency is given by FM. Highest frequency is given by FM. Then according to sampling theory, what is the sampling frequency? According to sampling theory, what is the sampling frequency? Fs? Sampling theorem gurtunda? Fs should be
2 FM.
greater than or equal to
2 FM.
equal to 2 FM. Greater than or equal to 2 FM. Suppose FM is equal to 4 kilohertz. 4 kilohertz. Then what should be the value for Fs? Should be greater than or equal to
8 kilo.
8 kilohertz. Then what is the meaning of 8 kilohertz? If Fs is equal to 8 kilohertz, then what is Ts? What is Ts?
1 by
1 by F.
1 by
T is equal to 1 by F, no? So Ts is equal to 1 by Fs. Then this is equal to 1 by 8,000. 1 by 8,000. See here, this is the message signal. This is the message signal. Okay, otherwise I draw. Suppose this is the message signal. Here I take the samples at an interval of Ts. Okay, like this. At an interval of Ts. If Ts is equal to 1 by 8,000, then the number of samples per second is equal to how much? You tell me. Here Ts is equal to some value, whatever it may be, 1 by 8,000. The number of samples per second is equal to how much? What is the value of that? Here Ts, this time period is equal to 1 by 8,000. The time duration between 0 and Ts, or Ts and 2s, or 2Ts and 3Ts is equal to 1 by 8,000. The units are seconds. 1 by 8,000 seconds. The number of samples per second. How many samples are there? Okay, I ask you in a reverse way. For example, a sinusoidal signal is there. You are most familiar with this one. The time period is here to here is given by T0. Suppose the frequency of fundamental frequency of the signal is equal to 1 kilohertz. What is T naught? Can anybody tell? What is T naught?
1.
1 by F, no? 1 by F means?
Yes, sir. 1 by 1000.
మీరు టెక్స్ట్ మెసేజ్ పెడితే నేను మొత్తం ఇదంతా ఇది స్క్రీన్ అంతా ఇదే చూస్తున్నాను. మీరు వాయిస్ తోనే చెప్పండి. 1 by 1000 and means 1 millisecond. Here this is 1 millisecond. T naught is equal to 1 millisecond. So in 1 millisecond, how many cycles are there? One cycle is there. In 1 millisecond, one cycle is there. In 2 milliseconds, how many cycles are there? In 2 milliseconds, how many cycles are there? 2 cycles are there. Then similarly, in 1 second, how many cycles are there? In 1 second, how many cycles are there? In 1 second. In 1 millisecond, one cycle is there. In 2 milliseconds, 2 cycles are there. In 1 second, how many cycles will be there? Hey, say 1 second means how many milliseconds?
60 seconds. 60 cycles.
How many milliseconds 1 second means?
60.
1000
milli.
seconds.
Huh?
1000 milliseconds. 1000 milliseconds is equal to 1 second, no? In 1 millisecond, one cycle is there. In 2 milliseconds, 2 cycles are there. In 1000 milliseconds, how many cycles are there? 1000 cycles are there. So that is equal to 1 second. So if Ts is equal to 1 by 8000 seconds, then number of samples per second. In 1 second, how many samples are there? Any samples are there? $8,000 samples. Number of samples per second is equal to 8,000 samples. 8,000 samples. 8,000 number of samples per second. Okay, you please note up. If Ts is equal to 1 by 8,000 second, the number of samples per second is equal to 8,000. Okay. So now we come back here. The message signal is there, whose highest frequency is given by FM. The highest frequency is given by FM. Then sampling frequency should be greater than or equal to 2 FM. Sampling frequency should be greater than or equal to 2 FM. Okay. Then what is the sampling? FS indicates. Actually, FS indicates number of sampling frequency, no? That is number of samples per second. You note that FS indicates sampling frequency. That is number of samples per second. That number of samples per second. So the number of samples per second should be greater than or equal to 2 FM. 2 FM. Okay. Next, you note number of bits per sample is equal to number of bits per sample is equal to number of number of bits per sample is equal to number of bits per sample. Already we have discussed how many bits are required for each sample.
N.
Yeah, number of bits per sample is equal to n. Then number of bits per second, number of bits per second is equal to, see, in one sample you need n bits. In one sample you need n bits. For 2 samples, how many bits are required? 2n bits. For 3 samples, how many bits are required? 3n bits. If suppose you take the fs samples per second. What is fs indicates? Number of samples per second. Number of samples per second is equal to fs. Number of samples per second is equal to fs. Number of samples per second is equal to fs. Number of bits per sample is equal to number of bits per sample is equal to n. Number of samples per second is equal to fs. From these two, can you tell me number of bits per second? Number of bits per second.
N into 2f. 2f.
Done. Done. Number of bits per sample is equal to n. Number of samples per second is equal to fs. From these two, can you tell me number of bits per second?
NFS.
Yes. N into fs.
FS.
n into fs. Number of bits per second is equal to n into fs. మన ఇంతవరకు యూస్డ్ నెంబర్ ఆఫ్ బిట్స్ పర్ సెకండ్, మన ఇంతవరకు జనరల్ గా మాట్లాడుకుంటున్న వర్డ్ ఒకటి ఉంటుంది, అదే ఇది నెంబర్ ఆఫ్ బిట్స్ పర్ సెకండ్. ఇప్పుడు మీకు ఇంటర్నెట్ ఉన్నది, వాట్ ఈస్ ద బిట్ రేట్ అంటారు. వాట్ ఈస్ ద బిట్ రేట్ అంటే చూడండి, మాకు ఇంటర్నెట్ 3 Mbps అంటాం. వాట్ ఈస్ ద మీనింగ్ ఆఫ్ 3 Mbps? 3 megabits per second. 3 megabits per second అంటే ఒక సెకండ్ కి ఇన్ని బిట్స్ వస్తుందని. సో దట్ ఈస్ నథింగ్ బట్ బిట్ రేట్, RB. This RB represents this one, number of bits per second. So what is the expression for RB? N into fs. N into fs. Okay, can you tell me in terms of fm? RB is equal to, because
2 into NFS.
fs is equal to 2fm, no? Then
2 into N.
2nfm. 2nfm. RB is equal to 2nfm or simply n into fs. 2nfm. Okay? If fs is equal to 2fm. If fs is more than 2fm, then RB is more than 2nfm. Like that. Okay? Next, you note down bandwidth of the channel. Bandwidth of the channel. Bandwidth of the channel. Bandwidth of the channel is given by RB by 2. It is a general expression, that is bandwidth of the channel is equal to bit rate by 2. Bit rate by 2. Bit rate ఎంత ఉంటే అందులోని హాఫ్ బ్యాండ్విడ్త్ అన్నమాట, హాఫ్ బ్యాండ్విడ్త్. Then what is bandwidth? N into f. N into f. So this is the expression for bandwidth of the PCM. Okay. So, okay, in this class, we have discussed about signal to noise ratio and bandwidth of the PCM. What is the signal to noise ratio of the PCM? You notes ఉంటారు కదా ఒకసారి చెప్పండి.
PM 3L square by MP square.
What is the what is this bandwidth?
RB by 2.
What is RB?
Bit rate.
Expression చెప్పండి.
NFS by 2.
Okay. I give you one problem. You please note down fast. A problem చెప్తాను ఫాస్ట్ గా నోట్ చేసుకోండి. నోట్ చేసుకుంటున్నారా? మీకు ఆల్రెడీ మెసేజ్ పెట్టాను. You come with book, pen and calculator. Okay, note చేయండి. A binary channel with bit rate RB is equal to a binary channel with bit rate RB is equal to 36 kbps. 36 kbps. What is the meaning of 36 kbps?
36 kilobytes per second.
36,000 bits per second. Okay. A binary channel with bit rate RB is equal to 36 kbps is available for PCM voice transmission. PCM voice transmission is available for PCM voice transmission. Full stop. Find appropriate values of the sampling rate FS. అంటే మీరు చెప్పాలి FS ఎంత తీసుకుంటే బెటర్ మీరు ఐడియా ఇవ్వాలన్నమాట. Find the appropriate values of the sampling rate FS, the quantizing levels, capital letter L, the number of quantizing levels L, capital letter L. Find the appropriate values of the sampling rate Fs, the number of quantizing levels capital letter L, and the binary digits N, small letter N. Full stop. Assuming FM is equal to 3.2 kilohertz. Assuming FM is equal to 3.2 kilohertz. Graded ఇచ్చాడు. RB ఇచ్చాడు. RB. What is the RB value?
36 kilo.
kbps. Okay, second. kbps. 36 kbps. Okay. Next, FM ఎంత ఇచ్చాడు?
3.2 kilohertz.
3.2 kilohertz. మీకేం ఫైండ్ అవుట్ చేయమన్నాడు?
Sampling rate.
FS ఫైండ్ అవుట్ చేయాలి. నెంబర్ ఆఫ్ క్వాంటైజేషన్ లెవెల్స్ ఫైండ్ అవుట్ చేయాలి. N ఫైండ్ అవుట్ చేయాలి. ఈ మూడు ఫైండ్ అవుట్ చేయాలి. ఫాస్ట్ గా చేయండి. N వాల్యూ ఎంత తీసుకుంటారు? L వాల్యూ ఎంత తీసుకుంటారు? N L చెప్పండి. FS ఇది ఇక్కడ బిట్ రేట్ ఇచ్చేసాడు. బిట్ రేట్ ఆర్బీకి ఎఫ్ఎస్ కి రిలేషన్షిప్ ఏమైనా ఉందా?
RB equals to NS plus.
ఇప్పుడు ఎఫ్ఎస్ కి ఎఫ్ఎం కి రిలేషన్షిప్ ఏంటి చెప్పండి. ఎఫ్ఎస్ షుడ్ బి గ్రేటర్ దాన్ ఆర్ ఈక్వల్ టు 2FM. ఆర్బీకి ఎఫ్ఎస్ కి రిలేషన్షిప్ ఏంటి?
RB equal to NFS.
RB is equal to NFS.
Yes.
So this NFS should be greater than or equal to 2FM, no? NFS should be greater than or equal to 2FM. 2FM కన్నా ఎక్కువ ఉండాలి. ఇక్కడ N తెలియదు, FS తెలియదు. N తెలియదు, FS తెలియదు. ఎలా సాల్వ్ చేస్తారు? బట్ ఆర్బి ఇచ్చేసాడు. ఆర్బి వాల్యూ 36,000 వాల్యూ ఇచ్చాడు. లెక్క ప్రకారం ఎలా ఉండాలంటే ఎన్ఎఫ్ఎస్ 2FM కన్నా ఎక్కువ ఉండాలి. 2FM కన్నా ఎక్కువ ఉండాలి. బట్ ఇట్ ఈస్ ఆల్రెడీ క్యాల్కులేటెడ్. దిస్ ఈస్ ఈక్వల్ టు 36,000. RB is equal to 36,000. Sorry, N వస్తుంది. N into 2FM. So 36,000 is greater than or equal to 2NFM. Can I write like this? Adanda RB is equal to NFS. But that RB should be greater than FS is greater than or equal to 2FM. 2FM can equal to but RB is equal to NFS. Indra FS value ఎంత కన్నా ఎక్కువ ఉండాలి? 2FM కన్నా ఎక్కువ ఉండాలి. అంటే RB should be greater than or equal to N into 2FM. No, FS is replaced by 2FM. So RB should be greater than or equal to N into 2FM. But RB is equal to 36,000. 36,000 is greater than or equal to 2NFM. You know FM, then can you tell me what is the value of N? N value చెప్పగలరా? Here 2NFM is less than or equal to 36,000. Then N is less than or equal to 36,000 by 2 into FM. 2 into FM. But what is FM? 2 into 3.2 kilohertz. 3.2 kilohertz. ఎంత వస్తుంది?
5.6 sir.
N is less than or equal to
5.625.
Okay, 5.6. But N is an integer, no? Number of bits అనేది మనకి డెసిమల్ వాల్యూ ఉంటుంది. సో మీరు N వాల్యూ ఎంత తీసుకుంటారు?
5.
4.
Okay, you can take any value less than or equal to 5.6. But nearest integer ఏది? 5. So let us take N is equal to 5. N is equal to 5. N is equal to 5 తీసుకుంటే అప్పుడు క్వాంటైజేషన్ లెవెల్స్ ఎంత వస్తాయి? L is equal to
32 sir.
2 to the power of 5. 32. 2 to the power of 5. 32. 1 minute. మీకు స్క్రీన్లో కనిపిస్తుంది కదా? సిక్స్ పాయింట్ 2.1 6.2.2 ఆ పిక్స్ తీసుకోండి, స్క్రీన్ షాట్ చేసుకోండి. 6.2.1 6.2.2 తీసుకున్నారా పిక్?
Yes, sir.
6.2.3 స్క్రీన్ షాట్ తీసుకోండి. ఓకే, 6.2. ఈ 3 ప్రాబ్లమ్స్ సాల్వ్ చేసి నా నెక్స్ట్ క్లాస్ సాటర్డే ఉంది. సాటర్డే 2 క్లాసెస్ ఉన్నాయి, మార్నింగ్ ఈవినింగ్. ఈ 3 నాకు సాల్వ్ చేసి వాట్సాప్లో పెట్టండి. వాట్సాప్లో ఎందుకు, ఈ క్లాస్ రూమ్ ఉంది కదా, ఈ క్లాస్ రూమ్లో పెట్టండి. ఓకేనా? ఓకే, బాయ్. ఈ క్లాస్ రూమ్లోనే పోస్ట్ చేయండి.